discussing Chiara Marletto's The Science of Kahn and Kant. I'm rereading the book, and I'm going to discuss what I understand under constructor theory and why it's so inspirational, because I think she's bringing up some new ideas that are worth pursuing. In particular, the idea that energy and information in the end are the same thing, and that we can actually express physics and the way the world works in terms of information, or to use her language, in terms of what's possible and what's not possible. This is a Not Even Wrong podcast. It's May 28th, 2022. This is Krim Telko. It's a Saturday. There's no update for the year. We are down 38.6%. The market's down 12.6%. We are underperforming by 26%. The Science of Kahn and Kant, the book that I've read about a year ago, is, I would say, a pivotal book in many ways, because I think it's particularly interesting because it looks at the world from a different perspective. And I think this is always a very important characteristic of books and ideas. Just before I go into the discussion for new readers, at Orange Capital Partners, we regularly discuss books, because it's not just that we like to talk about them and things like that. It is because this is part of the business. The purpose of this podcast is to give people a sense of what it feels like to run a hedge fund, and reading books is mental training, it's conditioning of the mind, and that's part of everyday activity that a hedge fund manager should be doing. So this is more than just a pastime. This is the job. So let's get back into it now. Again, Chiara Marletto's The Science of Kahn and Kant is an elaboration of constructor theory. Constructor theory is the idea that we can describe the way the world works, not in terms of dynamics, like in the sort of traditional way physics works, but in the answering the question, what can be done and what is not possible and why. This is roughly what she's talking about. So it's, or she calls it, counterfactual. So you have a 0 and a 1, and the world can be looked at that way in terms of what's possible and what's not possible. What does that really mean? So let's say she talks about the second law of thermodynamics, and she said, look, there's this kind of paradox, which is that we would like things to be symmetrical. Like if we go one way, we should be able to go the other way too. And let's say if you look at Newton's laws or Schrödinger and things like that, they're always dynamic situations where you start with an initial position and then you go somewhere based on some sort of function. And the question is, shouldn't you be able to reverse that? I mean, if it's a function, if you go from x to x squared, well, you should be able to go back from x squared back to x, right? By taking the square root. And for some reason, that doesn't work all the time in physics, because we have the second law of thermodynamics. And she talks about this, and then she comes up with this really nice idea. And the idea is that, well, maybe some things in physics are reversible and some are not. And actually, that's obvious. We know that some are reversible and some are not. Like if you break an egg, it's very difficult to reverse that back. But if you heat up something and then drive a turbine, you could relatively easily bring that kinetic energy back to the heat energy, and assuming you don't lose anything and all that. So the question here is more, what are the processes that actually are reversible and what are processes are not reversible? And that's where we start thinking in terms of energy and information. And energy, she says, look, we can just use the sort of old Greek definition. It's the capacity to work. I've recently come across another way to look at energy. Energy is basically a constraint function. So it allows you to do something under certain constraints. And it is given, we have the energy conservation law as part of the laws of thermodynamics. I think it's the first one. So the question now is, okay, why is it that some processes go one way but can't go the other way? And Marletto talks about this in a sense. Let's say, imagine if you had 3 lights, blue, red, and green. And every time you see the green light, that you know that prior to the green light there was a blue light. And every time you see a blue light, prior to the blue light there was a red light, and so on and so forth. If you follow that type of argumentation, then you can basically always reverse the process, because if you see a blue light, then it was red before, and if it was red, then it was green before, and so on and so forth. But now, what if the process was such that you see red and yellow is a mix of two colors. And when you see yellow, you don't know what came before. So she starts talking about physics in terms of sometimes maybe we don't know what was before because we don't have the information. And this could be actually a way to talk about also quantum information. Let's say if we have entanglement, so we know that some two things were entangled, but we don't know what they were before they got entangled, which exact setup they were. Then maybe that's why some processes are reversible and some are not reversible. So I think it's an initial start of thinking about the world in terms of information and in terms of energy transfer and energy in general in terms of information. That we have energy is in fact nothing but information, in a sense that there are processes in the energy transfer that are that could be expressed in terms of the capacity to store information. So, for example, we have an atom that gives up an electron to another atom. Now, that is a situation that we know this atom is -1 electron and the other atom is +1 electron. And if it goes from one atom to the other, it can go back. So this is a counterfactual. It's either here or there. And if we can think like that, and we extrapolate to a situation in physics where there's processes where we know it went from here to there, it's here or there, it's either up or down, or any of those types of like counterfactuals, it's 0 or 1, up or down, left or right. Now we can bring in, let's say, the Ising model, where we have the spins of atoms, and then we explain through the interaction with nearest neighbors how the whole, how the whole magnet is reacting. Once we start thinking about those types of things, we can see that, in fact, the magnet could be, of course, used for energy transfer. So it can be used in an electric car, for example. So we see that if we can express the interaction between the atom spins and then conclude how that affects the aggregate magnet and maybe the motor that drives, well, maybe we can also reverse the whole thing. And that's sort of the vague idea that I see here, that we can express energy transfer in terms of information. This is the big idea in the chapter where she talks about heathenwork. And I think, to me, it opens up a lot of ideas. First and foremost, how about I look at the world in terms of what can be done and what can't be done? And let's talk about fundamentally what can be done, what can't be done. In other words, let's not talk about things like, okay, well, we don't have the money to do it, or we're not there yet. So let's say, can we fly to Mars? Well, of course we can. There's no laws of physics that say we can't fly to Mars. Can we change the car industry to electric? Yes, we can. So once we start thinking along those lines, it becomes more interesting to look at businesses and the world in general. But I think, of course, we have to be very careful not to fall into tautologies here, because if I say that, okay, I can transfer the whole car industry into an electric car industry, what have I really gained? Can I really invest in companies based on that? No. So I have to be careful. But I think, again, it's an initial idea to look at the world in terms of what's possible, what's not possible, to look at the world in terms of counterfactuals, in terms of is it up or down, left or right, and then define processes based on that. So if the atom is -1 electron, the other atom is +1 electron, then I can conclude that the next atom is also going to be minus or plus, and maybe I can program a process in terms of what's possible and what's not possible, in terms of counterfactuals, and get results. And I think this is sort of where she goes with the constructor theory. The constructor being the universal constructor. So that's not just the universal computer, but the constructor. So you can build things. So she says in her book, it could be the ultimate 3D printer, where you put in any kind of design and it prints out whatever you want. I think that, to me, is becoming a little bit fuzzy in terms of, okay, fine. I mean, it's really just sounds like a 3D printer. So I don't want to get into the 3D printing conversation. That's not interesting to me right now. But what I found interesting is the idea that you can basically say the second law of thermodynamics, that entropy, or based on Boltzmann's comments and analysis and theories, that a system is such that it has the most likely state of either increasing entropy or staying the same. And that's based on what they called statistical mechanics back then. In other words, they analyzed, let's say, a system of gases, and they realized that the most likely scenario is that this gas will have either higher entropy or the same. And I think that in itself can be looked at. Well, you have a system that increases entropy because it doesn't remember the state before, so you can't reverse it. And systems that remember the state before, they can be reversed. So in that sense, it's an information problem. And the second law of thermodynamics can be expressed in terms of information. And I think this is what Chiara is trying to say in her book, and also in her speeches after she wrote the book, that we can look at physics from a purely information theoretic concept and basically stop with the distinction between physics and information theory and energy and information theory, and just look at everything as information. I think it's a beginning. I think it needs more work. I am still a little fuzzy about what it actually means, but I see through the fog, and that's very exciting. And I think looking at the world in terms of what's possible and what's not possible, looking at your life in terms of what's possible and what's not possible, and not just always be sort of obsessed with the dynamics. Even like, my son wants to become a professional soccer player. Well, is that possible? Yes. What's possible what's the next step he can do? Well, he can go and train and win a game. Like, those things are possible. What's not possible is he can't go to the World Cup. We start thinking more along those lines. Maybe somewhere down the road we get to interesting conclusions. It's a novel idea. It's a novel way of thinking. So it's too early to draw conclusions or to say, oh, we have the Holy Grail and this and that. I think it's an attempt by David Deutsch and Chiara Marletto and their co-workers to start a new branch of physics, which is more driven by information theory and which combines information theory and energy and physics, and the idea that we have physics as a sort of um, discipline that tries to explain how the world works. And that discipline is now being introduced, or we're introducing a new way of thinking into the discipline, which is, how about we think about everything that happens in the world as a series of counterfactuals that can be expressed in information theory, and that there is a way to either reverse systems or systems of energy transfer, and that is based on information that can be stored and regained, and then there's certain systems that cannot be regained. And maybe also, now that I'm thinking, this could be also a fact of the emergence, sort of the emergence phenomena, like emergent dynamics, emergent factors. When you have a convolution of things, you don't know anymore what the initial states were, and that's why we have the second law of thermodynamics. We have emergence, and maybe the second law of thermodynamics only works from our perspective, so meaning from the humans, in an anthropological sort of way. Maybe objectively there is no second law of thermodynamics. So those are interesting questions. Thank you.